Good morning, everybody. Today we're going to talk about three things: volts, amperes, and ohms. Three things we measure in a circuit. So again, I'm going to remind you what is a circuit. So when we had the battery, then you had the light bulb, and you have what we call the current. Remember, like electricity is electrons moving, right? So the electrons are moving here, and then we had so many electrons. So here, electrons, 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 and they go here, they go to the light bulb, and then they go. Okay? So what we want to know are these three words. Voltage, it's also called electromotive force, because what the battery does, so the voltage is always provided by the battery. And what does a battery do? Battery is always push, because electrons can't move on their own, so they have to be pushed. So what the battery does here is pushing the electrons to start moving. Okay, so here's the electrons, same here, right? This is what electrons are pushed. So this is your battery, and then electrons are pushing, and then here, this will be your light bulb, or any other load you can think of. But what they do, they say, oh, you can't go anywhere. So when you're pushing, you're sucking the energy out of electrons. Remember I said before there's $100? So imagine each electron says $100, and what the light bulb says, stops it, and it said, give me your money, give me your money. And the light bulb gets the energy from the electrons, and it gives you instead light. So the energy of the electron, it changes to light. Light. So sometimes they call the light bulb a resistor. What does a resistor mean? Something that resists means pushing back, stopping, not letting electrons to go. So when I push something and I create either light or I create heat. So basically three things. So here is my push. Here, the electrons, it's my current. The more electrons I have, the bigger my current. Electrons are moving, we have current, electricity. Then here, this little light bulb is my resistance, because as the electrons are coming, as they're coming, they have to lose their money here to the light bulb. So now they have no money, they go back to the battery. They get money, they come back, give it to light bulb, and then go back to the battery. Give the money, come back. So it keeps going again until the battery is dead. That's why you have to buy a new battery. Okay? So again, my battery is volt. My current, the electrons, is ampere. And my light bulb, which is resisting, it's called ohms. So here's the symbol of current. The symbol is showed by I. The unit, it's A, or amps. Now, how do I measure it? I will use something called ammeter. And I showed you that in that computer website that you could actually use to build the circuit. We saw the ammeter. I brought it here and I could measure the current in different places. So meaning, this is the meaning. The number of electrons that are moving. That's called current. Potential difference, voltage, electromotive force, sometimes EMF, different names, same thing. Pushing the electrons to move. Symbol V. Unit V, it's called volts. What do I use to measure? It's called voltmeter. Voltmeter. And this is the meaning. Resistance, the unit, the name, the symbol R. The unit is the symbol omega. If you ever seen some of these watches that they have, it's called omega watches. They use this symbol. It's a Greek symbol. It's called omega. And how do I measure it? Something called ohmmeter. Okay. Because in order for me to measure my current, measure my volt, measure my resistance, I need devices, right? Just like a ruler you use to measure length. You use a balance to measure kilograms, your weight, your mass. So these devices are used to measure my electrical components. One for current, one for voltage, and one for resistance. So this is what's called, okay? So these are the three things in a circuit. So we're going to take up the booklet now, okay? Another name for electric current is amps or ampere. Ampere tells us how many electrons, so it's the number of electrons, pass a point every second. So if I could put my eye in there and measure time, 1 second and 10 electrons are passing, I say they're 10 amps, okay? EMF, electromotive force. Another name for voltage. Electrical force or pressure is measured in a unit called volts. So voltage for battery. If you look at your batteries, you can see 10 volts, 2 volts, 1.5 volts. Electrical resistance measured in a unit called ohm. Okay, the symbol looks like this. It's omega. V is like that, and ampere is like that. So what is volt? Volt is electrical pressure. It's the force pushing. So number 1, D. Amps is the number of electrons passing a point. Amp means current. Current means electrons moving. Circuit is a path for electrons to move. It's like a street. That's a circuit. Ohm's law is the relationship between volt and amp and ohm. So what it means, a relationship means if my voltage changes, my current will change. If my resistance changes, my current will change. So therefore, somebody named Ohm decided to make a relationship between them. So that's called Ohm's law. And if you really want to know before you go to grade 12 or 11 physics, that's the relationship. The resistance is always equal to voltage divided by current. What's ohms? Ohm is a resistance. So A. So true, false, EMF stands for a number of electrons. That's false. EMF is the force, it's the voltage. Another name for resistance is ampere. That's false. Another name for resistance is ohm. Volts measure electrical pressure or force. That's true. Different circuits have different amps, volts, and ohms. That's true. If volt changes, then the amp and ohm stay the same. It's impossible, right? They have to change too. One thing changes, the other ones have to change. Electricity that is not moving called static. Electricity that is moving called current. Friction produces static. Remember, friction is another name for rubbing. Rubbing, if you rub a balloon with a fabric or like your comb, that creates static electricity, friction. A dry cell produces current. A battery gives me current electricity. That's why I use wires. The electricity we use is called current. We don't use static electricity for a TV or anything. Current electricity is a flow of electrons. The only thing can move in an atom are electrons. Most current electricity comes from generators. Dry cells can't give me too much electricity, therefore I use generators, big things that they produce big electricity for, like Hamilton, Toronto, big places. The circuit that only has one path to follow, one path, is series, one. More than one path, that will be parallel. Home, schools, factories are wired in parallel because I don't want one room to go off and the entire to go off. I want one room on, one room off. If all appliances are on or all off, that's what I get a series circuit, like street lights or Christmas lights. Any number of appliances on or off tell me the circuit is parallel. So I could have some off, some on, that's parallel. Change of wire length of thickness, it does affect electrical. The longer you have to travel, the more resistance. For example, if I have a very long wire, then electrons have to travel longer distance, then it get hot. Nichrome has high resistance. This is a wire they use in your iron. You know, when you iron your shirt, inside your iron, there's a metal called nichrome that actually has very high resistance. So stopping the electrons so much, and it gets so hot because of this resistance. You know, when you're fighting somebody, you get hot. And same thing as a wire. A high resistant wire builds more heat. If it's so much resistance, it gets hot. That's why your light bulb gets hot, and that's why it gives a lot of light. It has to get hot first. That means so much resistance first. A low resistance gives you a little heat. Copper is a low resistance. Why? Because they want to use it in your house, inside your walls, inside your, devices, like any electrical devices. If the copper gets too hot, then your home will be on fire because the walls get too hot and then there will be fire. So copper is a low resistance. I don't need copper. Like, I'm not going to use nichrome in my house because then my house will burn because the wires get, because imagine you have iron inside your walls. You don't want that. The size of an electric current is measured in ampere. Electrical pressure measured in volts. And electrical resistance, ohms. Again, this is your light bulb, this is your battery, and this is the electrons moving inside the wires.